So I'm going to solve the M coloring problem, which is we are given an undirected graph with n vertices and e edges. So the goal is to determine whether if the graph can be colored with only M colors, such that no adjacent vertices have the same color. So firstly, I will be constructing the graph. The given edges are n. So we'll make a vector int graph consisting of n edges initialized to 0. Then I will do for int I is equals to 0, I less than edges dot size I plus plus to go over all the edges. Then I'll construct the graph by graph edges dot I, the ith edge, the first element dot back, pushing back all the edges with the vertex I. So edges I1. Since the graph is bidirectional, we will construct two edges for each. So 1 and 0. So initially all of my graph is uncolored, so I'll go on and no, sorry, this one was okay. So I'll go on and make a vector in color with n and all initialized to 0, the n edges and all initialized to 0. Then I'll go on and return function coloring that I will make. That takes in an argument graph. The argument in the first, the color vector. It will also take in a vector the first node, the current node, and m and n. So I'll define a bool. Since the return type is bool, I'll define a bool method coloring, which takes in vector int, and referencing the memory will take graph, then a vector int and color, which takes in the vector color, then int node, and int m, and int and the number of vertices. So if we have reached the last node, we can simply return if node equals to n, we can return 2. Then we'll go on for all the color combination with is 1 to m. So for int current color is equals to 1, current color less than equal to m, current color plus plus. So we can check if the color combination is possible or not. So we will make a function if is save the current color, the graph, the color vector, and that's it. So is save. We'll do color, current color, sorry, color with current node changing to current color Then we'll go on and call the coloring again with the graph, the current color node plus 1 for the next node, M and N. Then we uncolor the node again, the int color node. So we have also have to set the previous. So color, oh sorry, int copy color is equals to color dot node, color dot node is equals to again copy of color. So this way we be able to backtrack and return false. And here, if this method returns a true, we'll return a true. Then we'll go on and define a save function is save which takes in vector of vector. So vector int and graph. Then we'll take a current, sorry, okay. So current int current column vector int graph vector int color referencing the memory of color. Okay. So then we have go on and like so we also have the current node. So we'll go and take it as input node and here in node. So this way we can check if this node and all of neighbors, none of it should be same color. That's the only way it is safe to color safely color this node also the color apart from this. So we'll for auto it graph the current node if it's all of its neighbors it not equal sorry sir color it not equal to current color sorry is equal to current color. So if mm, so if it's equal then we could simply go on and kind of false. If none of it is same then we could simply return true. This current color is safe return false. This looks good. Let's go and run and try this. So it's accepted, so it's running fine. So thank you.